Hello and welcome to this AQA Further Math Statistics video. Chi-squared tests 2, this time looking at Yates correction for 2x2 contingency tables. So using the chi-squared test you met in the previous series of videos looking at contingency tables and chi-squared testing. So you should be familiar with working with contingency tables and finding a chi-squared test statistic to test for association. And the formula that you should be familiar with is given here and is in the formula book. We are going to be looking at the special case of a 2x2 contingency table in this video, and in that particular case it's convention that the chi-squared test stat is slightly amended. And this is the test statistic that is used, and the reason for that is that with a 2x2 contingency table, our degrees of freedom nu are the lowest they ever can be. They're just 1. And that means that our critical value from the chi-squared tables is the lowest it can be for whatever level of significance we're working with. And therefore we do have a risk of a type 1 error occurring, and therefore the test statistic is slightly amended in that we look at the modulus of the difference between O and E, so the positive difference between those two, and we subtract a half from that difference before we square, as before, this numerator and divide by the expected value. And those are summed to get our slightly amended chi-squared test statistic in the case of a 2x2 contingency table. So you might just like to pause a moment and read this example through and just absorb the information. We have it nicely summarized in the contingency table here. We are categorizing the people involved as either children or adults, and we are looking at what dessert choice they preferred. And we have our 122 people here, and the row and the column totals conveniently written down for you. And we've been asked to investigate for an association between dessert choice and whether the person is a child or an adult, using a 5% level of significance, and to then comment on any association that may exist. So performing the test you should be fairly familiar with. So we state our null hypothesis, that's always no association, and you can put no association between dessert choice and whether the person's a child or an adult if you like, or just simply put no association. And our alternative hypothesis is that there is some association. And then the steps we follow are, first of all, to create a table of expected values or expected frequencies, and those are evaluated based on the statement in the null hypothesis that there's no association, that the dessert choice and the age of the person are independent of each other. We then create a table of contributions to the test statistic. So for each cell, each reading we had originally, we look at that O minus E, modulus of that difference minus a half squared divided by E. We then sum those contributions to get our overall chi-squared test stat. We then look up the critical value in the chi-squared tables in your formula book, and remember, for a 2 times 2 table, your degrees of freedom will always be 1. Your degrees of freedom are number of rows minus 1 multiplied by number of columns minus 1, so we always have 1 degree of freedom for a 2x2 table. We will then draw our conclusion to accept or reject the null hypothesis, and then put that in context and identify the main sources of association if we've indeed found that association does seem to exist. So let's look through our example. These were the observed values or frequencies that we had originally. We're then going to work out our expected values, and if you recall, our expected values, and they're written down here, if we just look at the expected value for chocolate and children, that would be our row total for children multiplied by our column total for chocolate divided by our grand total. So just familiarise yourself again with how we obtain these expected values, and remember that you should always give those to 2 decimal places. And also remember that we only have 1 degree of freedom, and therefore actually as long as you've got your first expected value correct, all these others you can just fill in by subtracting from the relevant row and column totals. So we then have to work out the contributions to the test stat, and this is where we differ slightly from what we did before. So when you have a 2 by 2 table, the first thing to do is to work out the modulus of the difference between O and E. So there's no negative values there, we're just looking at the positive difference between the two. We then subtract a half from that, so we're going to be reducing the numerators that we have. And you'll notice when you start to work this out that the differences between O and E are the same for all 4 categories there, and therefore the numerator in each case is going to be 3.21. And if we work out our contributions to our test stat, we're going to be looking at 3.21 squared over 34.29, 3.21 squared over 12.71, etc. And we then use that formula to sum those values and obtain our overall test statistic. And you might like to just pause a moment and check that you can indeed obtain the expected values and obtain these contributions using this new formula here. So working out our test statistic, you should find that when you sum all the contributions, you get 1.807. So 1.81 is probably sufficient accuracy. And remember that our degrees of freedom are 1, so we now need to go to the chi-squared tables in the formula book, and we're going to be having a look for 1 degree of freedom, and we're doing a 5% test. And if you remember, chi-squared tests are always one tail, so we have 5% here, or a probability of 0.05 of falling in this area. So P is 0.95, and that gives us our critical value as 3.841. So in the example we're looking at, our test statistic is 1.81 and our critical value 3.841. So 3.841 is our critical value at 5% and our test stat 1.81. So clearly our conclusion would be that our test stat is less than the critical value. So we are going to accept the null hypothesis. And to make our conclusion in context, we would then say that there is no significant evidence, and that's at the 5% level, to suggest any association between, and this is where we do need to talk about the actual context of the question, dessert choice and child or adult. And comment on any association that may exist. Well, obviously this is more or less covered here. We cannot comment on any, right, because there is no significant evidence of any association. And obviously if we had rejected the null hypothesis, we would then have to go back and look at our table of contributions to the test statistic, and we would then have to decide where the major sources of association were lying. And that concludes this video.